Assalamualaikum and hello. In this video, we are going to learn how to describe or compare the boiling points of carboxylic acid. We are also going to learn how to compare the boiling point between carboxylic acid and alcohol as well. So there are a few steps that I want to teach you as a tip in order for you to arrange the compound if you got 3 or more compounds. First step, you have to determine which compound can form hydrogen bonding. You have to give the suitable reason, and please include dimerization for carboxylic acid. Step number 2, determine which compound could form weak van der Waals forces. Van der Waals forces here, you can use specifically either London dispersion forces or dipole-dipole forces. London dispersion forces is for non-polar molecules and dipole-dipole forces is for polar molecule. Next one, you have to compare the molecular size. And last but not least, step number 4, you have to arrange in correct order. So these tips only applicable when you want to use comparison between 2 or more compounds. So if you got 2 compounds, you don't have to arrange. If you got 3 or more, you have to show the arrangement. So let's go to example 9. I got a few cases here. We will focus one by one. For case 1, you have to compare the boiling point of the following compounds. I have propanoic acid and 2-butanol. So as you see here, this question already give you the structure and the name. So if you want to use the unknown as your labeling, it's fine when you want to write down so that you can save the time. But if you want to straight away use the name propanoic acid and 2-butanol, it is also acceptable, but make sure your spelling is right. So next, what I'm going to do right now, I'm going to describe in the bullet points based on their comparison of boiling point. So if you take a look here, between propanoic acid and 2-butanol, both of them can form hydrogen bonding. So propanoic acid, you got carboxyl group here, and for butanol, you got hydroxyl group. So what will happen? Both of them can form hydrogen bonding. I use short form HB. But the special thing about propanoic acid, this is carboxylic acid, it can also form dimer. So hydrogen bonding with dimer. So you can conclude that propanoic acid has higher boiling point than 2-butanol. So the first point, you have to tell which one has the highest boiling point. So as I mentioned before, propanoic acid has higher boiling point than 2-butanol. So this is the first point. And the second point, tell me the reason why you choose propanoic acid has the highest boiling point. So you can write it down as due to stable hydrogen bonded dimer between molecules. So I'm going to write it down as this is because propanoic acid can form, put the adjective stable, hydrogen bonded dimer. So this is where you're not only say about hydrogen bonding, but you also emphasize about dimer. So use the term stable hydrogen bonded dimer. And don't forget, this is between molecules. And when you want to compare, you don't leave out 2-butanol. So I will put while 2-butanol can only form this one, hydrogen bonding. So this will be your explanation for case 1. You got 3 marks here. The first mark is about your statement, which one has higher boiling point. You got 1 mark here. And the next one, you got second mark for propanoic acid can form stable hydrogen bonded dimer. This is your second mark. And the last one, 2-butanol can only form hydrogen bonding. So this is the third mark. So I hope all of you understand how to answer based on example in case 1. That's it for this video. We are going to focus for the next case in the next video. Thanks for watching. Bye.